up with section 5.5 today, which is still U substitution, but now we're going to do it for definite integrals. So let's do one for an indefinite integral real quick, just to kind of refresh on the U substitution, get a refresher. So example, let's find the integral of secant of ln of x times tangent of ln of x, oops, okay, nope, over, what is it, x, just x. And we're going to integrate that with respect to x. And so remember, the first thing that you're going to do is you're going to determine what your inside function is, because that's what's going to kind of determine what you make u equal to. And so what in this case is going to be our inside function, or our u? Yeah, the ln of x, right? Because that's kind of trapped inside of another function. And so here you have u is equal to ln of x, and then when you find du, so technically you find the derivative of u with, the derivative of u with respect to x, and so that's going to give you 1 over x. But then you want to find what du is equal to, and so you get 1 over x dx. And then now I can substitute this for du, and I can substitute this for secant u tangent u, right? And so here we're going to have that this is equal to the integral of secant of u times tangent of u, and then we're going to integrate that with respect to u. And so here, what do I take the derivative of to get secant tangent? So what's the antiderivative of secant tangent? It's one of the trig functions, right? It's not sine or cosine. When you differentiate tangent, you get secant squared. Yeah, it's going to be secant. So here you're going to have secant of u and then plus c. And so be careful when you put your plus c's into web work, make sure they're capitalized. I want to say a few of them specify that, but not all of them. But okay, so here's secant of u plus c, and then what's the very last thing I need to do here? Because I don't want to find this in terms of u, so what do I need to do? Yeah, you need to plug in ln of x for u now, so you just need to undo that substitution. And so you're going to have secant of ln of x plus c, and so this right here is the answer. Okay, so are there any questions about how to do this with indefinite integrals? Because now we're going to talk about definite integrals and the u substitution. Okay, so then let's look at an example. So we're gonna have the integral from 0 to the square root of pi of x sine of x squared, and then we're going to integrate that with respect to x. And so to start these ones with these limits, right, the lower and the upper limits on it, we're going to start it the same way that we would if those weren't there. So we would start it the same way as if it were an indefinite integral. And so here, what is my inside function going to be? What would u equal in this case? Yeah, that x squared, right? Because it's trapped inside of sine. And so here you're going to have that u is equal to x squared. So du is going to equal 2x dx. And then I can make all the substitutions again. What's the only thing I need to do? What's the only problem that's here? because I don't have that exactly. So what do I need to do? Yeah, it's the 2, not the x, right? Because the x is right here. And so I do have x dx. I just don't have 2x dx, right? And so I just need to divide by 2. And then, yeah, plug in 1/2 du. And so you're going to get that this means 1/2 du equals x dx. So this now, and we have to be a little bit careful here. I'm not going to put my limits just yet for a very specific reason, but what I can do is I can say that this is sine of u du, or 1/2 du, so I'll put the 1/2 out front real quick. So 1/2 sine u du. But is it correct now to put my limits as 0 to the square root of pi? Is it okay to have those 2 green highlighted limits? No, right? The issue is that when I have 0 and the square root of pi, I am integrating with respect to x. And so these are values of x, but what I want to have here are the values that I would get for u, right? And so what I need to do is, and I'll write this down as like a note in a second, but what I need to do is I need to figure out what these limits would be by using the equation that we found up here, right? And so you're gonna get that when you have x, you can make a little table, and this is u, or here. So how do we want to do this? Yeah, so u is equal to x squared. And so here you're gonna have 0 square root of pi. When you plug 0 in for u, you're just going to get 0, and here you're just going to get pi. And so now you have 0 to pi. And so let's make a little note. Wait, you guys said the blue is not good. So let me change that real quick. Oh no, it's going to change the... Okay, so note the limits have to match the variable of integration. And the variable of integration is the variable that's given in the like the d whatever, right? So like dx, du, etc. I actually just realized my pencil's gonna die, which is a strange sentence. But so we might have to take like a 5-minute break. But so yeah, here you're integrating with respect to x, and so the limits should be values of x. But when you start integrating with respect to u, your limits should be values of u. And so what you can do, this is probably the easier way to do it. I'm going to show you a different method where you do not have to worry about the limits. But for now, like this is kind of like method 1. And then you just kind of take care of this the way we did up here, right? It's still, you can still think of it as an integral. And so what's the antiderivative of sine of u? So I already know that 1/2 is going to be there because it's just a constant. But then what's the antiderivative of sine? Yeah, it's cosine, but it's a negative cosine, right? Because then when you take the derivative of cosine, you get negative sine. And so you want to make sure that you get rid of the negative, right? So it's going to be cosine of u. And then here, since we've already figured out what the limits are for u, I can just put those down right there. So I can use the second part of the fundamental theorem of calculus to figure this out now. And so here we're going to get negative 1/2 times the cosine of pi minus negative 1/2 times cosine of 0. And so here, let me move this. It's starting to look a little clunky. And so here you get that cosine of pi is -1. And so here you're getting negative 1/2 times negative 1 minus cosine of 0 is positive 1. So this is positive 1/2 plus 1/2, so the answer here is 1. So are there any questions on, and so I'll call this method 1. And then I'll do another method right now. Okay, so the second method is, instead of figuring out what the limits for u would be, we can kind of just ignore them until we get to the end, and then we can put back in the limits for x. And so method 2 would be so here, the original problem is from 0 to the square root of pi x sine of x squared dx. We're still going to have the same value of u. But what we're going to do now is we're going to find the definite integral. So look at just the integral of sine of x squared dx first, and then evaluate that at the limits that you have. And then you never have to convert your limits to u. And so you get the same thing. You get that u is equal to x squared, 1/2 du equals x dx. And so here you're getting 1/2 times the integral of sine of u du. And then when you integrate this, you get negative 1/2 cosine of u plus c, because now it's an indefinite integral. So this is the same thing that we had before, right? Right here, just with the limits now. And so now the only thing that's different is we have this plus c right here. And so if this were an indefinite integral, the next thing we would have to do is, rather than plugging in the limits, I would plug back in the thing for u. So negative 1/2 cosine x squared plus c. Now that you know what the indefinite integral is equal to, you can just evaluate this at the limits that you were given for x, right? And so now you can evaluate this at the limits given for x. And so here you're going to get that the indefinite integral from 0 to the square root of pi x sine x squared dx equals negative 1/2 cosine x squared. You don't need that plus c because it's just going to cancel itself out, right? And so you're going to evaluate this from 0 to the square root of pi. When you do that, you're going to get cosine of pi, which again is negative 1, minus the cosine of 0. And so again, you're getting the same answer of 1. It's just two different ways to solve it. So I know I did that second method pretty quickly, but it's because a lot of it was just the same as the first method until the very end, right? And so go ahead, write that down. Let me know if you have any questions. Yeah, so I was saying you can choose whichever method you want. I'm never going to ask you to pick between the two, right? So just get comfortable with one of them. But so if we look at this example, what is the inside function that you're going to pick here? So this one's a little bit trickier than the other ones we've done so far, right? But so what do you guys think u is going to equal? It's actually just going to equal 1 plus 2x without the square root. And the reason why is because when you take the derivative of that square root, you would get another square root, but we only have 1, right? And so here, you know, u is not going to have that square root in it, because then you would get something like 1 over the square root of whatever, right? And so I'm just going to have 1 plus 2x, which means that du is just 2 dx. So what is missing in du that I have here? Yeah, that x. And so we've come across this. We ran into an example like this on Wednesday. What can I do to kind of get rid of that x and put it in terms of u? Where else do I have an equation that relates x and u already? Yeah, the u equals 1 plus 2x. So if I take this and I solve this for x, you would get that x equals 1/2 times u minus 1. So real quick, let's just kind of write down. So the goal, whenever you're doing u substitution, is to convert all x's and dx's to u's and du's, right? And so this is kind of like one trick that you're gonna see quite a few times. So keep it in mind when you're doing the homework or working on like quizzes or something like that. But so here when I replace everything, and so real quick, let's take like a little mini, I didn't create a poll in Zoom for this because I didn't think about it until right now. But just type either method 1 or 2. Which one do you guys like? 2, 1, 1. So far it's a 50-50 split. Oh, still 50-50. Okay, now 1 is winning. Oh, 1's winning more. All right. Oh, 1 is winning by 1 person. I'll do it both ways. So let's do the first method first, right? So if I know how u and x are related, then for each value of x that I'm given, I can find the corresponding value of u. So 0, 4. So u is equal to 1 plus 2x. And so when I plug in 0, I get u is 1. When I plug in 4, you get 9. And so method 1 would be having your integral grow from 1 to 9 of 1/2 times u minus 1 over the square root of u du. And this still looks pretty complicated, but what do you think I'm going to do to make it easier without doing any more substitutions? Oh, you know what? Hang on, I just realized something. I kind of forgot about this, but this 2 dx, I don't actually have a 2 there, and so I'm going to have that 1/2 du equals dx. And so here, I'm just missing a 1/2, and I'm just going to put that out front. So I'll write that in like green for right now, just because I forgot it. Okay, so yeah, what do you guys think I'm going to do with all of these u's? What can I do with this square root? Yeah, I'm going to write it as u to the negative 1/2. And so when you do that, if I bring this 1/2 over to this 1/2, then that's how I'm getting 1/4, right? But so you have 1/4 times the integral from 1 to 9 of u minus 1 times u to the negative 1/2 power. You're going to integrate that with respect to u. And then now I'm just going to take this and distribute it. And then it's 2 simple integrals, right? And so here, this is 1/4 integral from 1 to 9, u to the negative 1/2. Oh, wait, hang on. No. So here, this is u to the first power. So u to the first power times u to the negative 1/2 power. You're going to add those. And so you're going to get u to the positive 1/2 power. And then u to the negative 1/2 power. Du. Okay, so this is the point where it really starts to get different. So the only difference between method 1 and 2 is in method 2, you're just not going to have these limits here, right? And so, and then this next step, you're just going to have a plus c. And so this is where, this is the only time it really starts to differ. And so here, 1/4 u to the, okay, so what's the antiderivative of u to the 1/2? What am I going to have? I know I add 1 to the power, but then what else do I need out front to kind of get rid of that power? Yeah, 2/3 u to the 3/2. So you're going to have 2/3 and then minus, and then u to the negative 1/2 power. I'm going to do the same thing again, right? So I'm going to add 1, but then if I were to take the derivative of that, I'd get 1/2 u. And so you're going to multiply that by 2. So you're going to get 2u to the positive 1/2 power. And it stays minus right here because that stays unaffected. And then, so yeah, if this were method 1, I would put a plus c right here, and then I would convert those u's back to x's, and then I'd plug in 0 and 4 for x. And so, but we're doing method 1 right now, and so I'm going to evaluate this from 1 to 9. And so here you get 1/4 times 2/3, and then this is 9 to the 3/2 minus 2 times 9 to the 1/2. Just kind of write this down for now. I'll tell you what the answer is in a second. Okay, when you do all of that, you're gonna get, oh man, I never actually found the answer. 1/4 times 2/3 times 27 minus 6 minus 2/3 plus 2. So whatever that gives you, that's what your answer is. Oh yeah, no, I don't want to deal with all those fractions. Okay, but is everybody okay with this part of it? And so here, now I'm gonna branch out. So right here, I'm gonna treat this as, or here, how should I do this? I'm gonna go on and do method 2. And I'm just gonna pick it up from that line. So for method 2, I'm gonna be looking at the integral, or wait, sorry, wrong line. From here with the integral still. So I'm gonna be looking at the same integral, just, oh man, I keep drawing it from the wrong line. This one. Just without the limits, right? So I'm gonna have 1/4 times the integral of u to the 1/2 minus u to the negative 1/2 du. And so it's gonna give me almost the same exact thing. The only thing is I'm gonna have a plus c, so this is 1/4 times 2/3 u to the 3/2 minus 2u to the 1/2, and then plus c. Can you guys see the green okay? And I said the blue wasn't very good, so I thought maybe the green would be better. Oh, it looks okay on my screen. Okay. All right, so here, the next thing that you're gonna do, since I don't have the limits yet, since I technically Is there a darker green? Yeah, there is. But since I technically didn't find the limits for u in my second method, then I can't plug in my limits for u here. So I'm gonna plug in what I found for x again. So I'm gonna have 2/3, and then u is equal to 1 plus 2x. So 1 plus 2x to the 3/2 minus 2 times 1 plus 2x to the 1/2 power plus c. And then now I'm going to evaluate this at the limits of x, and so I'm just going to get rid of that plus c. And so here I'm going to evaluate this from 0 to 4. And when you do that, you get the same thing, whatever this is right here. Did anybody do this yet? Did you guys find an answer for this? Also, keep in mind, this one is going to be a little bit more complicated than this one. Okay, so is everybody okay with these examples or these two methods? Are there any questions about this? All right, let's do one more then, just to kind of make sure. So here, for this example, we're gonna have the integral from e to e to the 4th of 1 over x times the square root of ln of x dx. And so let me write that all out so it looks better. 1 over x times the square root ln x dx. Okay, so one thing I didn't really talk about when it came to notation of integrals is that some people would write this as the integral of e to the 4th dx over x times the square root ln of x. When I first started taking calculus, I want to say the first person I took it with, because I took it multiple times, the first person I took it with said that this is bad. The second person I took it with, I'm currently using her notes, and she writes it this way. So I think it's really just a matter of opinion. But so yeah. Actually, you guys may have also had the person I took calculus with. If you've had Amber Rosen at Cal Poly, that's who I took it with. Anyway, yeah, so you can choose whichever one you want, right? But I'm gonna stick with, I personally don't like writing it on top. But okay, so here u, what value or what function do you think u is gonna be in this case? Which function is like trapped inside of another one? Yeah, that ln, right? Because it's inside that square root. And then something nice happens when you find the derivative of that with respect to x. You see that you actually have that, right? 1 over x dx. And so you don't really have to play around with this too much. So here you're going to get the integral from 1 over the square root of u du. And so if you do method 1, then you're going to have to convert everything. I guess everything, just these two things, right? So e and e to the 4th. And so here, when you plug in e for ln, you're gonna get, this is just 1, right? Yeah, it's just 1. And then this is 4, right? Because ln of e equals 1, ln of e to the 4th equals 4. And so here you're gonna get 1 to 4. And then you can rewrite this as u to the negative 1/2, which we've already seen. And then here, this is going to give you 2u to the positive 1/2 evaluated from 1 to 4. So this gives you, what is this, 3? 2 times 2 is 4, minus 2 is 2. Cool, there we go. So that one was a little bit shorter, but if you can do that one, then you should be okay on most of the homework. Actually, no, if you can do the example we did right before that one, then you'll be okay on the homework. Oops. So yeah, do you guys have any questions about U substitution?